Soil and Human Health Part 2 Alfalfa, Nature's Lesson in Biological Restoration, number 1723, July 20th, 2026, Gerald C. EclaireMD Foundation, Category Soil Science and Human Health. Preface. Today, I read a Chinese article on gardening whose main points are summarized below. Many home gardeners have noticed that over the past few years, nitrogen fertilizer prices have risen dramatically. A bag of compound fertilizer now costs more than twice what it used to, despite spending much more money. The soil often becomes harder and more acidic with each growing season. Eventually, seedling survival rates decline, while earthworms and beneficial microbes gradually disappear. In reality, restoring soil health does not require buying chemical fertilizers year after year. Alfalfa, commonly called jinhu, a vegetable in Taiwan, and koutu in Taiwanese, which was introduced to China more than 2,000 years ago, serves as a natural, free nitrogen factory. The root nodules of alfalfa contain nitrogen-fixing bacteria that convert nitrogen gas from the air into nutrients that crops can absorb directly. Its deep taproot can penetrate 1 to 2 meters into the soil, breaking up compacted layers. As the roots decompose, they release organic acids that help unlock phosphorus already trapped in the soil. In other words, a single plant performs 3 important functions at the same time: nitrogen fixation, soil loosening, and phosphorus activation. This explains every step from selecting the appropriate variety, inoculating the seeds with rhizobium bacteria, sowing, and field management to the ideal time for incorporating the plants back into the soil. It also points out a critical detail that most gardeners overlook. Missing this step can greatly reduce the benefits of all the previous work. The methods are suitable for both home vegetable gardens and balcony container gardens. By following them, you can reduce dependence on chemical fertilizers and gradually develop darker, looser, and healthier soil. Key techniques: choose the right variety for home gardens. Use green manure alfalfa jinhu, a vegetable which has a short growing cycle and decomposes quickly. Avoid forage-type purple alfalfa. Critical step: before sowing, inoculate the seeds with alfalfa-specific rhizobium bacteria. This can increase nitrogen fixation efficiency by approximately 40 to 70%. Best timing: incorporate the plants into the soil at the early flowering stage when the first flowers appear. At this stage, both the nitrogen content and rhizobium activity are at their highest. Field practice: turn the plants into the soil at a depth of 10 to 15 centimeters for 2 to 6 inches. Water thoroughly to accelerate decomposition, then wait before planting the next crop. Additional tip: leave 10 to 20% of the alfalfa growing around the edges of the garden instead of incorporating all of it. This helps maintain phosphorus activation, attracts pollinating insects, and provides greater long-term improvement of soil health. Growing vegetables is never about bargaining with the land. Chemical fertilizers are like borrowing nutrients from the soil. If we only borrow and never repay, the soil's fertility will eventually be depleted. Planting alfalfa, on the other hand, returns nutrients to the soil and gradually restores its natural ecosystem. When the soil becomes healthy again, the vegetables will naturally thrive. One small scientific note: the passage is generally consistent with established soil science. The statement that alfalfa activates phosphorus is a simplified description. More precisely, root exudates and associated soil microorganisms can increase the availability of some phosphorus that is already present in the soil, rather than creating new phosphorus. This nuance may be useful if you plan to use the concept in your own research writing. Body of information: my previous article, The Cotton Field and the Human Body Part 1, introduced a simple but powerful idea: healthy soil and the human body are both living ecosystems. Long-term restoration comes not from forcing the system with increasing chemical inputs but from rebuilding and respecting the underlying biological environment. Recently, I learned another fascinating lesson from agricultural soil science. Many farmers have become increasingly dependent upon chemical fertilizers to maintain crop production. Although fertilizers can temporarily increase yields, excessive dependence gradually hardens the soil, increases acidity, disrupts beneficial microorganisms, and weakens the living ecosystem that healthy farmland depends upon. Agricultural scientists have long recognized a remarkably elegant natural solution: alfalfa. For more than 2,000 years, farmers have planted alfalfa not simply as another crop but as a biological partner for the soil itself, through a symbiotic relationship with rhizobium bacteria living within its root nodules. Alfalfa captures atmospheric nitrogen and gradually returns fertility to exhausted land. Its deep roots loosen compacted soil, while the biological activity surrounding its roots improves nutrient availability and encourages the return of beneficial microorganisms. Rather than forcing the soil, alfalfa strengthens the living system itself. As I reflected upon this farming practice, I realized that the same principle also applies remarkably well to human health, particularly to the long-term rebuilding of my own pathophysiological system. The living soil and the living body. Healthy soil is far more than a mixture of minerals. It is a living biological community composed of fungi, insects, microorganisms, organic matter, earthworms, water, air, and plant roots that continuously interact with one another. The human body is remarkably similar. Our health depends upon the harmonious interaction of trillions of cells, blood vessels, nerves, hormones, immune cells, mitochondria, beneficial intestinal microorganisms, and countless biochemical pathways working together as one integrated biological system. Neither soil nor the human body remains healthy through chemistry alone. Both are complex living systems governed by the integrated interaction of biology, chemistry, and physics. Alfalfa is nature's teacher. The remarkable feature of alfalfa is not merely that it grows, it improves the environment in which it grows. Instead of extracting nutrients while leaving the soil weaker, alfalfa gradually restores the soil's own ability to sustain future crops. Its roots penetrate deeply into compacted ground. Its associated bacteria convert atmospheric nitrogen into forms that plants can naturally use. Its biological activity encourages healthier soil structure and a richer underground ecosystem. The result is not simply better crops. The result is healthier soil. That distinction is extremely important. Lifestyle medicine functions in the same way. Over the past 17 years, I have gradually reached the same conclusion regarding my own health. Healthy nutrition, regular physical activity, adequate sleep, emotional stability, proper hydration, and a healthy gut microbiome do not merely improve laboratory-tested numbers, they improve the biological environment in which every cell functions. Lifestyle medicine resembles alfalfa. It supports the human body's own capacity for repair, adaptation, recycling, and regeneration, just as alfalfa enriches the soil without forcing it. Healthy daily habits strengthen the body's internal biological ecosystem without overwhelming its natural physiology. The healthier that ecosystem becomes, the more resilient the body becomes. Medications and fertilizers. This philosophy should never be misunderstood. Chemical fertilizers are valuable agricultural tools. Likewise, medications are among the greatest achievements of modern medicine. Antibiotics have saved millions of lives. Insulin transformed diabetes care. Anti-seizure medications protect the brain. Antihypertensive medications reduce the immediate risk of stroke. Particularly, emergency surgery rescues patients who would otherwise die. These practices and therapies are indispensable. However, neither fertilizers nor medications should be expected to accomplish something they were never designed to do. Fertilizers cannot completely restore damaged soil biology. Similarly, medications alone cannot fully restore the body's underlying biological ecosystem. They treat disease. Lifestyle medicine supports health. These are complementary, not competing roles. Emergency medicine and lifestyle medicine is sturdy. My wife required 13 hours of emergency medical evaluation and comprehensive diagnostic testing at Stanford Hospital after her systolic blood pressure ESBP rose above 158 mmHg and her heart rate exceeded 146 bpm. Watching the physicians systematically assess her condition reminded me once again of the extraordinary value of modern emergency medicine. When life is threatened, rapid diagnosis, laboratory testing, medical imaging, clinical judgment, medications, and emergency treatment become indispensable. There is no substitute. Emergency medicine saves lives, yet emergency medicine naturally raises another important question. Once the immediate danger has passed, how do we reduce the probability that another similar emergency will occur? The answer often lies outside the emergency department. It begins years earlier. It begins with maintaining the body's biological ecosystem through weight reduction, particularly for many Americans. Healthy nutrition, regular exercise, restorative sleep, emotional balance, adequate hydration, and other healthy daily habits that help maintain healthy levels of glucose, blood pressure, and blood lipids. Lifestyle medicine cannot prevent every disease, however, by strengthening the body's internal resilience. It may substantially reduce the likelihood that many chronic disorders eventually progress into medical emergencies. Emergency medicine restores life during crisis. Lifestyle medicine helps reduce the probability of future crises. Both are indispensable. Each serves a different purpose. Respecting the living system. Many farmers eventually discover that increasing fertilizer indefinitely does not continually improve the soil. Instead, the healthier long-term strategy is to restore the biological processes that naturally maintain soil fertility. The same lesson applies to human health. Our objective should not simply be to pursue better laboratory values through increasing medications whenever possible. Rather, our first objective should be to preserve the remarkable biological ecosystem that nature has already provided. When that ecosystem remains healthy, physiology functions more normally. When physiology remains healthy, disease becomes less likely. When disease becomes less likely, the need for emergency intervention may also become less frequent. This does not diminish the value of medicine. It places medicine within its proper role. Medicine saves lives. Lifestyle medicine helps preserve them. Perhaps that is the deepest lesson that soil science of agriculture has taught me. Healthy soil supports healthy plants. Healthy physiology supports healthy organs. Both remain healthy not because they are continually forced, but because their living biological systems are continually respected, nourished, and restored. Reference summary from original Chinese article.
很多菜友都有感觉，这几年氮肥价格越涨越夸张，一袋复合肥涨了2倍有余，钱花下去不说，土反而越种越硬，越种越酸，到最后菜苗死亡率节节升高，蚯蚓和有益菌都不见了。其实养土根本不用年年砸钱买肥料，早在2000多年前就传进中国的苜蓿，台湾俗称金花菜，台语叫草头，就是天然的免费氮肥场。根部的根瘤菌能直接把空气中的氮气转换成作物可吸收的养分，主根还能钻进1-2米深的土层破坏板结，腐解后释放的有机酸更能活化土里被锁住的磷肥，一种草同时搞定固氮、松土、活磷3件事。今天这支影片从品种选择、根瘤菌接种、播种管理到黄金发芽时机，手把手全部讲清楚，还会告诉你90%种菜的人都会忽略的关键细节，做错了前面所有努力都大打折扣。家庭菜园、阳台盆栽都是有，从此不用依赖化学肥料，土越种越黑越疏松，重点技巧整理。品种选择：家庭菜园选绿肥型苜蓿、金花菜，生长周期短，腐解快，勿买牧草型紫花苜蓿。关键步骤：播种前务必接种苜蓿专用根瘤菌，固氮效率可提升4到7成。黄金时机：出花期，第一波小花冒出时翻芽，此时氮含量与根瘤菌活性最高。操作细节：翻芽深度10到15公分，浇透水加速分解。等待2到3周再种下一茬。加分秘诀：菜园角落留1到2成苜蓿不翻，持续活磷，吸引授粉昆虫，长期养地效果翻倍。种菜从来不是和土地讨价还价，化学肥料是向土地借营养，只借不还，终究会耗尽地力。而种苜蓿是把养分还给土壤，慢慢把生态养回来，土健康了，菜自然长得旺。
This content is provided for educational reference only and does not constitute medical advice. No doctor-patient relationship is created. You may share this summary freely, but it must not be altered, edited, or republished as your own. All intellectual property rights and copyrights for this article and its related materials belong to the author, Gerald C.